Alaikum sir. My name is Muhammad Junaid Anjum. My faculty number is 20EEHM005. My enrollment number is GG0998. As my topic is AI based condition monitoring techniques. Now coming to the next slide. And my subtopic is condition monitoring of DC motor using artificial intelligence. There is some contents which is given below. Introduction. First point is introduction. The second point is need of condition monitoring. The third point is need of artificial intelligence based technique. The fourth point is online condition monitoring. The fifth point is offline condition monitoring. The sixth point is advantages. Seventh point is disadvantages. And the eighth point is application. And the ninth point is conclusion. Coming to the next slide. First of all, I want to discuss about introduction. Condition monitoring is the process of monitoring is the parameter of condition in machinery, vibration, temperature, etc. in order to identify a significant changes, which is identification of a developing fault. It is a major component of predictive maintenance. The use of condition monitoring allows maintenance to be scheduled or other actions to be taken to prevent consequential damages and avoid its consequences. Condition monitoring has a unique benefit in that condition that would shorten normal lifespan can be addressed before they develop into a major failure. Condition monitoring techniques are normally used on rotating equipments, auxiliary system and other machinery, compressor, pump, electric motor, internal combustion engines, presses, while periodic inspection using non-destructive testing techniques and fit for services evaluation are used for static plant equipment such as steam boilers, piping and heat exchangers. Now coming to the next slide. Need of condition monitoring. Condition monitoring of electrical machinery can significantly reduce the cost of maintenance and risk of unexpected outage by allowing the early detection of potentially catastrophic faults. The second point is condition based maintenance is having an accurate means of condition assessment and fault diagnosis. The next point is by condition monitoring, we can perform the continuous evaluation of the health of plant and equipment throughout its serviceable life. The next point is condition monitoring and protection are closely related function. The approach to implementation of each is however quite different. Also, the advantage is that the monitoring are entirely different to those to be expected from protection. This is principally because monitoring should be designed to preempt faults, whereas protection is essentially retroactive. Condition monitoring has to establish a map between input signals and output indications of the machine condition. Classifying machine condition and determining the severity of faults from the input signal have never been easy tasks and they are affected by many factors. Now coming to the next slide, need of artificial intelligence based technique. A human expert can be subject to influences that make quick and consistent judgments impossible, mainly when there are many machines in the plant. The second point is correct judgments may also depend on knowledge and experience of many experts who are not all available at the same time. The next point is manufacturers are adding more functionality to new machines while the utilities are more focused on aged, existing and machines to extend their usable lifetime. The next point is it has been realized that human expert facing a condition monitoring task will receive a large amount of data, some of which may be little important but while others are important. Now coming to the next slide. Online condition monitoring. From this type of monitoring, we can obtain the data like current, temperature, vibration, axial flux, speed. Some of the following are visual monitoring. This method ranges from a simple visual inspection by the unaided eye through to the use of bore scopes for better access, microscope to increase magnification, and closed circuit television cameras. They are not recorded automatically. The second point is motor current signature analysis. In electrical machine, some faults can be detected by measuring the currents or voltages in the machine windings. The magnetic field created near electrical machine changes when fault occurs. The third point is vibration monitoring. This is a very widely used technique which is commonly implies a piezoelectric device to sense the acceleration of a moving part. The fourth point is temperature monitoring. Machine faults such as an unbalanced shaft will increase the friction in the bearings and therefore the temperature will increase. Thermal sensor can be used to detect such changes in temperature and therefore detect the fault. The fifth point is flux monitoring. Flux monitoring is used to observe differences in the nature of the axial leakage flux into an indication of fault condition. Now coming to the next slide, online monitoring process block diagram. This is the basic block diagram of online monitoring process. Coming to the next slide, offline condition monitoring. The first point is insulation resistance. From this type of monitoring, we can perform the data of insulation resistance of field, ground to field resistance, field winding resistance, insulation resistance of field. The insulation resistance test measures the resistance of the electrical insulation between the copper conductors and the core of the stator or the rotor. Ideally, this resistance should be infinite since, after all, the purpose of insulation resistance is to block current flow between copper and the core. The second point is polarization index. The polarization index test is a vibration of the insulation resistance test. Polarization index is the ratio of the insulation resistance measured after the voltage has been applied for 10 minutes R10 to the insulation resistance measured just after 1 minute. A low polarization index indicates that a winding may be contaminated or soaked with water. Now coming to the next slide, advantages. Following are the advantages of condition monitoring techniques. The main benefits of condition monitoring is the lowering of maintenance cost. The second point is maximizing production output. The third point is increasing lifespan of machinery. The fourth point is prioritizing maintenance tasks. Now coming to the next slide, disadvantages. Monitoring equipment. Monitoring equipment cost usually significant, a skilled personnel needed, a strong management commitment needed. The second point is a significant run in time to collect machine histories and trends is usually needed. The third point is the sensors employed to take the measurement are quite costly. For example, the sensors used in the rotor diagnosis are vibration pickups, accelerometers, piezoelectric transducer, which are very costlier as compared to other transducers. Now coming to the next slide, application. So many applications are given below. Mining industry, cement industry, pulp and paper processing industry, steel production industries, food manufacturing units, oil industries, transport, military. Now coming to the next slide, conclusion. The first point is accurate means for condition monitoring can improve the reliability and reduce the maintenance cost of the DC motor. The second point is condition monitoring involves sampling sensor signals, processing these signals to extract features which are sensitive to the presence of fault, deciding if a fault exists and identifying its type. The third point is condition monitoring has to establish a map between input signals and output indications of the machine condition. The fourth point is classifying machine condition and determining the severity of faults from the input signals have never been easy tasks and they are affected by many factors. So, using artificial intelligence technique, we will solve this problem easily. Now coming to the next slide, thank you.